In this two video lectures over there, this is lecture 1 in which I will try to complete a revision for chemistry O level, IGCSE and Pearson Edexcel over there with all the papers related to practical, alternative to practical section and the paper 1 for O level and paper 2 for IGCSE and paper 2 for O level and paper 4 for IGCSE, paper 6 for IGCSE and paper 4 for O level, like that. And Pearson Edexcel paper 1, paper 2. I am trying to conclude all the syllabus in these two video lectures over there. And if you will try to revise, then I will try to summarize in a best way as much as I can over there. Okay, let's start towards our topic. It is related to chemistry. Okay. Chemistry is basically branch of science in which we study about matter, its physical and chemical properties, its reactions, and the laws which causes those reactions and changes over there will be studied in chemistry over there. Basically, first of all, we will have to go for matter, which is everything which has mass and occupies space is called matter. Matter is existing in nature for chemistry point of view in three main states, that is solid, liquid, and gas over there. Solid has a fixed shape over there. Liquid have not any fixed shape. They takes the shape of its container over there. Gas don't have any fixed shape and takes the shape of its container. It can be a room, it can be a small closed jar over there. That can be taken for shape point of view. If we go for volume, solid and liquid have fixed volume while gas has no any type of fixed volume over there. Solid has the regular arrangement in their atoms state over there, and liquid molecules are randomly moving at every point over there, and gas molecules are also showing the random motion over there. If we talk about separation, then I will say they are tightly packed. Tightly packed means they are showing any regular arrangement in their atoms, and they are having very less separation between their molecules. While in case of liquid, we can say they are loosely packed over there, and in gas, they are far away from each other at larger separation they are available. And when we look towards the solid, we say that they have strong forces of attraction. Liquid have less forces of attraction over there, and gas have very little forces of attraction over there. And we can also say that if we talk about motion, solid shows the vibratory motion over there, like they show to and fro motion along the fixed position over there. In case of liquid, they slide over each other because they can flow and they are randomly moving. So liquid and gas both can overall be named as fluid because their matter can flow from one point to another over there. Kinetic energy in case of solid is very low because it is not losing its position. They are showing only to and fro vibratory motion over there. In case of liquid, they have high kinetic energy, and in case of gases, they have very high kinetic energy of the molecules over there. We can't compress, we can't decrease the size of solid by compression by exerting pressure over there. We can't decrease the size of liquid also. And in case of gases, we can compress them with a strong force if we want to decrease the volume section over there. If we talk how the pressure increase is possible, there are three main methods to increase the pressure in case of gases over there. Then I will say if we decrease the volume, definitely pressure will increase. We will say pressure and volume are inversely proportional to each other over there. If we talk about temperature, then we will say pressure and temperature are directly proportional to each other. And add more gas means we will say related to volume over there, related to number of moles over there. If I will increase the number of moles of gas, pressure will also increase over there. When we decrease the volume, what will happen? There will be molecules will come closer together. and there will be very large number of frequent collisions will be happening over there inside the of the wall. Thus pressure increases in that case over there. And when we say temperature is increasing, definitely temperature and kinetic energy are directly proportional to each other. Then we can say when kinetic energy is high, molecules are moving at faster speed, they collide more frequently, pressure will increase over there, showing the directly proportional relation over there. And number of moles, if I increase the volume of gas over there, if I increase the number of moles of a gas, definitely there will be larger number of molecules to collide with each other to exert extra pressure over there. So there were three main ways where pressure was playing its role over there. If I talk about kinetic theory of gases or kinetic theory of matter over there, I will say that the particles move all the time. In case of solid, vibratory. In case of liquid, they are showing random motion. In case of gases, they are showing the random motion over there. As there is higher temperature, there is a faster movement of the molecules. Like if I increase the temperature of those particles, they will start to move with faster movement. In case of solid, they start to vibrate with larger amplitude. And in case of liquid and gases, they start to go for convection over there, like from higher temperature to lower temperature, they start to run away from there with larger kinetic energy. A matter's state can change by heating or cooling, but particle size never changes over there. So keep in mind, when you change the state from solid to liquid, liquid to gas, like that, solid to liquid or liquid to gas, never change the size of molecule, never change the size of particle over there. If we talk about diffusion, diffusion, for example, you are throwing your perfume in the corner of a room, and after some time, what will happen? That whole room will be feeling the fragrance over there. So this flow of gas molecules from the corner of the room to the whole room over there is showing that the molecules from higher concentration are flowing to the lower concentration over there. In case of liquids in liquids, gas in gas, liquid in liquid, for example, you are taking a glass of water and you are putting one drop of ink into water. The after some time, the whole colorful solution of that ink will be prepared. That is because of diffusion. So in general, I will say particles move from higher concentration, move randomly from areas of higher concentration to the areas of lower concentration over there. That is called diffusion. And diffusion basically depends upon four main factors, where I will say diffusion is if temperature is high, diffusion rate will be high. If there is windy, then also will be higher. If there is a larger surface area or like that, that will be higher rate. And if there is concentration gradient difference is larger, then definitely it will be higher rate of diffusion will be happening over there. Gas in gas, like perfume in the air, is the example. If solid in liquid, solid must dissolve first over there. For example, you want to dissolve table salt into water. To make the solution over there, then definitely we will have to dissolve the whole table salt first. If the liquid in gas, we are saying then liquid must evaporate first to become a gaseous state over there, and then it can involve the diffusion phenomenon over there. There are two main factors of diffusion where he has shown over there that if temperature is higher, rate of diffusion will be faster over there. Like rate, or we can say speed, will be directly proportional to temperature over there. In case of mass, I can say that mass is smaller, rate of diffusion will be larger. And if I want to conclude an example over here, then I will say that we should stay like, for example, I am taking the two compounds here like HCl and ammonia. In case of ammonia, the molar mass is just like 14 for nitrogen and 3 for hydrogen here, because three atoms, because hydrogen is having one mass multiplied by 3, so it is 17. And in case of HCl, that will be 36.5, like that, because HCl is 35.5 and 1 is added from hydrogen, 36.5 total. So which will show the rate of diffusion at larger rate. So when the mass is smaller, rate will be higher. When mass is larger, rate will be lower over there. And if I look here, the example where he is saying lighter gas will travel more and heavier gas will travel less over there. This can be HCl and this can be ammonia over there. Okay, this was a little bit diffusion which I was explaining over there. Now I am going towards the processes convergence over there. And if I talk that this is a solid, I am providing heat to it and it is being converted into liquid state, like little bit this regular arrangement is being little bit disturbed and they start to slide over each other, then I will say that endothermic process heat is provided to this solid to start melting over there, will be called the process in which solid is converted into liquid, will be named as melting over there. This is solid, this is liquid. So in this case, I will say particles gain kinetic energy because you are providing endothermic heat from outsides to the system over there. They vibrate faster until energy enough to overcome the forces of attraction due to which they are tightly packed over there. They move further apart and become liquid over there. On the other case, in the next step, if I say that liquid is converted into gas state over there, this is also endothermic process and I will have to provide in heat in over there. And in this case, particles gain kinetic energy of the liquid and they move faster until the energy is enough to overcome the forces of attraction, like in liquid case, like covalent bonds and hydrogen bonding is available over there. Then they move further apart and become gas and the bubble rises to the surface over there. So this is the process in which solid is converted into liquid and liquid is converted into gas. But if I say that directly going to solid is directly going to gaseous state, gas like that, then I will say it is called sublimation over there. If I take towards the reciprocal process over there, for example, I take these are the gaseous molecules and I want to convert them into liquid state, then it will be exothermic, means heat is coming out. Heat is taking out over there, out. And what will happen, that condensation process will be happening over there, that gas is converted into liquid state over there. In this case, I will say that particles lose kinetic energy and they move slower over there. They regain forces of attraction over there and they move closer together and become liquid. So this process is called condensation over there. And if I talk that liquid is converted into solid, then this is called freezing over there. Particles lose kinetic energy and they move slower than even though liquid over there. They regain forces of attraction and they move closer together and become tightly packed, forming a solid in a proper regular arrangement. That is called freezing process, and that is also named as heating out process. Heat out process. If I talk that gas is directly converted into solid, and if gas is directly converted into solid, then this process will be named as deposition over there. And this process is happening with, I will say, carbon dioxide, dry ice, solid carbon dioxide, where we named as dry ice over there. Dry ice, naphthalene, iodine are showing the phenomenon of sublimation and deposition over there. All right, here he has also given the sublimation examples like carbon dioxide as dry ice, iodine as black solid to purple gas. Like if I heat up the solid iodine that is in black color, it will convert its color to purple gas over there. All right. After that, he is going towards the heating curve and cooling curve. For example, the material is available at solid point, and here it is time, and here is temperature in degrees centigrade over there. Remember that temperature has three main scale: degree centigrade, Fahrenheit scale, and Kelvin scale over there. And if I talk about it, I will say, let's suppose you are providing heat and temperature of the solid is increasing in this pattern over there. Then what will happen? There will be a melting point at which when the temperature reaches melting point, it will be staying its temperature in uniform state. It is not going to increase because here it is temperature increase is shown over there. And if I talk about it, I say that even though you are providing heat but temperature is not increasing because heat provided is completely being consumed for the conversion of solid to liquid state. So this process is called melting. When all the solid is converted into liquid state, then temperature is again starting to increase over there, and we can say when it reaches to the boiling point over there, it is again staying as it is. So this is the change of state. Change of state. Change of state at position A, change of state at position B, and both of these processes are going to be taken as a change of state, melting and boiling. Remember that both, if they are pure, like you are using pure water or you are using pure alcohol like that, then melting and boiling points will be sharp like 100 degrees centigrade for water, as boiling point and melting point is 0 degrees centigrade like that. So these will be sharp. But if the impurities are added, your melting point will decrease, melting point will decrease, and boiling point will be increasing over there. Elevation of boiling point and depression of melting point will happen if impurities are added over there. And if I talk about cooling curve, this is just like a reciprocal process named as condensation and freezing over there. When gas is converted into liquid at its boiling point over there, because gas molecules are at higher temperature and you are providing a decrease in temperature by doing the exothermic process over there. Condensation will happen when all the gas will be converted into liquid. Temperature will not decrease more. At liquid, they are staying as it is and they are not showing any type of decrease over there. In freezing, again, change of state is happening and temperature is not decreasing. It is staying as constant to make it solid over there. After that, if we talk about temperature does not change for the some time during the melting and boiling because energy is being used to overcome attracted forces between particles over there. So here he is explaining the same thing as I told you, elevation and depression of boiling point and melting point over there. Melting point and boiling point are not sharp. They are in range. If the impurities are present in any substance over there, melting point will decrease. Mostly when we observe that in Canada or USA countries over there, what happens when there is too much snow and there is ice on the roads, they throw the add the salts on the roads. They throw it, they spread it so that impurities can be added and ice can't be pure, and its melting point or freezing point should decrease more and more, and the roads can be staying wet over there. So boiling point is there. Elevation will be shown that 100 degree centigrade is water. Boiling point will not be sharp 100. It will be 110 and 120 if the impurities are added. The more impurities, the bigger the change in melting point and boiling point will happen over there. And in the last, I will say there is a comparison in case of evaporation and in case of boiling point over there. Evaporation is basically, if I define it in proper words, I will say escape of escape of gas molecules, escape of high kinetic energy molecules, high kinetic energy molecules from the surface of a liquid. Escape of high kinetic energy molecules from the surface of liquid is called evaporation at every temperature. It occurs only on the surface over there. It causes cooling effect, like you are going for taking bath over there, and after that you will come and you feel During the bath, you are not feeling any type of coldness over there, but after bath, you start feeling coldness. Reason behind that, the high kinetic energy of water molecules which are touching your skin starts to leave the surface. And because room temperature is 25 or like that, but your body temperature is 37 and they have high kinetic energy, they start to leave your surface and you feel the cooling effect over there. So this and boiling is to happen only at its boiling point over there. So here we can say evaporation is a slow process, occurs at all temperatures between melting and boiling point over there. Every temperature can happen, and it occurs only on the surface of a liquid over there. But boiling is rapid, occurs only at boiling point, and occurs throughout the liquid over there. So this is the complete introduction which I tried to show related to change of state, related to matter, related to diffusion, related to kinetic molecular theory over there, and processes conversion. I tried to explain. I think it will be giving you much and more stronger concepts related to this topic. Let's move to the next, what he is saying over here. Which type of apparatus we are using in our practical chemistry over there? We need to know stopwatch is used to measure the time for any event happening over there or the completion of any process. There is a measuring cylinder to measure the volume to the nearest 1 cm cube. Easy and quick to use. This is called measuring cylinder, volumetric cylinder over there. And conical flask is used to put the liquids in it for mixing and swirling over there. Gas syringe is used to measure the volume of a gas over there, because it is when it is increasing its volume, more gas can easily entering over here. There is a pipette to measure a fixed volume of liquid accurately. Size can be 10 cm cube, 25 cm cube, and 50 cm cube also over there, but it is slow to use over there. In case of burette, if I talk about it, burette is used to measure the volume up to the nearest 0.1 cm cube, and it is slow to use over there, and it is used for titration experiments only over there. After that, there is retort stand, which is used to hold the other apparatus like the funnel, like the conical flask, like the burette, or anything which we can which can be used to hold it apparatus to show the experiment over there. There is crucible with the lid to heat the solids over there, so that no energy can be lost outside. There is evaporating dish to evaporate the solution over there. There is a watch glass to hold the solids, to cover the beaker over there. There is spatula. Spatula is used to transfer solids over there. And there is a pestle and mortar. So it is used to crush the solids, like the crystals should be grinded properly over there. After that, there is a separating funnel to separate the immiscible liquids. Like you are taking water and oil, you just pour them into it, and what will happen? Oil will have the less density, it will start to float over the surface of water. Water has the high density, it will staying down over there. After that, he is showing here the sandpaper to clean the metal surfaces, because mostly the metals are showing a little bit corrosion over their surfaces. To make them shiny over there, we use the sandpaper. There is glass rod to stirrer to shake the solution. There are tongs to fit hot items or to hold them into it. There is a beaker to store and mix and heat the liquids. There is a thermometer used to measure the temperature. There is a wire gauge to support the apparatus. There is a trypan span to support the apparatus. There is a Bunsen burner, which is having the spirit lamp over there, and spirit starts to burn, and to heat the substances should be provided over there. After that, there is upward, downward, and over water and gas range, like how we will get the gases. Downward delivery, like when we will put our gas jar opening with its mouth towards the upper side, when our molar mass of the gases should be greater than 29 at least, so that will the gas is the heavier than this. So in this case, I will say we can take the example of ammonia, NH3 there, that is having the 17 molar mass. so it will be smaller, so it will be means I will have to get greater one. Okay, oxygen, like O2 is having the mass, molar mass of 32, it greater than 29. For carbon dioxide, it will be 44 there, will be greater than. So by greater masses, it will be collected like downward. And if they are having a gas lighter than air, like having molar mass smaller than 29, like that, like I can take N2 nitrogen, H2 hydrogen, like that, or F2 fluorine, if you are going for it. So all of them are having their molar mass is less than 29. So there will be upward delivery method, means the gas jar will have its open mouth towards down over there, and gas will be collected over water to measure the volume of gas that is insoluble over there, will be being used over there, that is insoluble. And bubbles are coming and collecting over the clamp over there, and bubbles are, when collecting this this gas is making the water to come down over there, and gas is collected over water over there. Gas syringe is used to measure the volume of any gas which is produced during any reaction over there. And there is separating chemicals over there, so hold the liquids in ceramic wool or cotton, like here I have this HCl gas or like that. And then when the gas is coming out because of the evaporation process over there, then it is being coming out and separate to liquids using separating funnels, we can use to separate out into the funnel over there, is being completely understandable over there. If we talk about safety measures, after that, there is a separate liquid by putting it in a test tube and handling it using a thread over there. Like they should not mix, or if they, because that is a water bath down or some heat providing source, and you are heating up this, like it should not get the flame, or fire should not be coming directly in contact with them. So we will use this method over there and place a divider inside a conical flask to separate out two chemicals over there. There should be a separator. After that, what should be the precautionary measures? What should be the safety measures in while working in the chemistry laboratory over there? No running, no eating or drinking, tie hair should be done properly over there. Wear lab coat, gloves, and goggles. We don't look into an apparatus containing chemicals, because it can emit any toxic gases or anything which can harm your delicate organs of your human body. Point test tube away when heating, because there is possibility that some um, material due to heat can come out and can make your body hurt over there. Don't heat alcohols using Bunsen burner, because they are flammable. Use electric heater or water bath. Use the fume cupboards or well ventilated areas when dealing with toxic gases. Use this always. Prevent suck back by removing the delivery tube from the liquid before stopping heat over there. And you should look that if this symbol is made on any material containing bottle over there, then it is corrosive, don't touch it. If it is done this, don't make any flame near to such type of object over there. Okay, now I will have to move towards the processes. So, first of all, I will say that we will have to talk about filtration. The first process which I want to talk is filtration over here. Filtration is the process in which we obtain an insoluble solid from a mixture over there. For example, sand from seawater. If you want to do so, what you will do it, you will just put the water and sand into the filter paper containing funnel over there. The residue, the sand will stay upward, and the water which is containing minerals over there will coming as filtrate. So filtrate is the liquid obtained after filtration passing through filter paper, and the undissolved substances which are present into that solution as a mixture will remain as a residue. And the filter paper is the paper which is separating both of them, and funnel is an optical, or we can say transparent funnel made for this purpose over there. So filtration can be done by decantation. Decantation is pouring of the liquids having the solid behind, like some solid is present over there, and you are just pouring off the liquid and solid is settling down in the base. Centrifugation, like heavier solid settles at the bottom due to spinning and the tube at high speed, like washing machine purposes being done over there. After that, the second process is related to evaporation. Evaporation, like obtain a solid from a solution. If it is a salt, the anhydrous form can will be obtained from salt from seawater. Like you are taking a seawater over there, you are heating it up, water is completely evaporated, and you are getting a solid salt at the base of the container over there. So heat the mixture in an evaporating dish. Solvent will evaporate and solid will be left behind. So definitions will be related to solute, solvent, and solution. Solute is the substance dissolved in solvent to make a solution over there. So any salt, any solute, any object which can dissolve into the solvent over there, that is called solute. Like I am taking sugar and water. Sugar will be solute, water will be solvent. So liquid in which solute is dissolved to make solution is called solvent, and the solution is a mixture obtained when one or more solutes are dissolved in a solvent over there. So here he is showing that how the evaporation can happen, like all the water molecules are evaporated and remaining the salts which were present in seawater will settle down there, and for this process we will get a solid there. After that, there is crystallization. Crystallization is a process in which we obtain a soluble solid from a solution in the hydrated form. Why we get in hydrated form? Because if we will get totally anhydrous solid over there, we will not get the crystals. Like I say, you 100% remove water from copper sulfate salt over there. What will happen? That when 100% water is removed, I will get only the powder form. I will not get the proper crystals over there. So for hydrated form, getting over there, we go for crystallization process, and the less soluble solute will crystallize first, and most soluble salts will be taken for this example. So I will say we will have to heat up over there, like heat until crystallization point, and cool, filter out the crystals and dry them on a filter paper. Don't use heating purpose for drying them. So crystallization is the process in which crystals are formed as a saturated solution cools down. Saturated solution is a solution which contains the maximum amount of solute dissolved at any fixed temperature over there. So I will say, for example, I start to dissolve table salt into water, and at room temperature I put, for example, 3 spoons, and they are completely dissolved. I start add more and more salt over there. What will happen? There will be a point that when I will stir it more and more, no more salt is going to dissolve at room temperature, and it starts to settle down at the base over there. And at that stage, I will say that is a saturated solution over there. And solubility is the amount of solute that dissolves in 100 grams of a solvent at a given temperature over there. So that is called solubility over there. Make sure that the flask is sealed at the top. Okay, now we will have to make towards the simple distillation over there. So that was related to crystallization. Now I am going towards simple distillation, like obtain a solvent from a solution and obtain pure water from a solution over there. If we want to get a pure water, make sure that the flask is sealed properly, like as he has shown over above here. Flask is properly sealed over there, and at the top with the bung to prevent loss of water, because water vapors should not go out, they should go towards the condenser. They should go towards the condenser over there, and condenser is filled with cold water from the bottom up, so water would fill it up over there. So for this whole process, we will say only two compounds, like water solution is present and you want to separate out water over there, you can use this process over there. After that, there is fractional distillation, in which like petroleum, like a complex mixture, is going to separate out their liquids in the gaseous state at their boiling points. So obtain a liquid from a mixture of miscible liquids, or obtain a gas from a mixture of gases like air over there. This is called fractional distillation. Like ethanol from a mixture of ethanol and water is separated out by using a fractional distillation over there. So for this process, I will say method works because the liquid have different boiling points. Like in petroleum, we know that natural gas is there. There is uh, petrol, there is diesel, there is jet fuel oil. So everyone have their own different boiling points over there. The liquid with lower boiling point will be obtained first, because it will be converted at lower temperature, because it is having low boiling point. It will uh, come towards lowering of the boiling point temperature over there. So boiling point will be obtained first, then we can collect them in the form of vapors, and condenser is there, and that fraction can be obtained. Fractionating column provides high surface area to condense liquids with higher boiling points. Thermometer helps to tell you which liquid is being collected over there. And fractional distillation is used to separate out liquid air. This is example, like liquefied air. You want to collect oxygen, nitrogen from the air, then this is the best technique to do so. And if you want to go for fractional distillation of petroleum, like to separate out natural gas, petrol, diesel, after that we can say jet fuel oil, kerosene oil, asphalt, naphtha, everything can be separated according to their boiling points by using this technique over there. After that, I will have to go towards the last section, where is related to chromatography. Chromatography is a technique in which separate a mixture of a soluble substance. Basically, this is not a separation technique. This is a technique in which we detect, we check the sample, like which way is being added, like the dope test. Mostly the athletes which are internationally representing, like they are working with their natural power, or they are using some energy boost or banned drugs over there, will be testified by using chromatography. Or we can say the celebrities, like international celebrities, but the food they are getting, they are properly testified by their medical team first, by using this technique of chromatography. A mixture of colors, mixture of amino acids, mixture of sample sugars and components of ink can be detected, can be we can say checked or identified, that which compound is present in that mixture will be done over there. For this whole process, I will say that we should go for a chromatography paper. Draw a line near the bottom with the pencil, like you have drawn this line. Till this line, you will say drawn with pencil, like this one. This till this line, we will put our sample mixture at this point over there, and on this line place few drops of the sample. So in a red color little bit they are placed, and place the chromatography paper in a beaker containing a suitable solvent. Mostly we take water, so that the pencil line is above the solvent. So it should not dip into water, it should stay above. And now allow the water to run up the paper to separate the substances. That process is called capillary action. Capillary action. So capillary action is a process in which filter paper is getting water to move up and up and up over there. So individual spots will indicate the number of colored substances in the sample. And if the sample is colorless, like mostly proteins are not available over there to show any type of color, so use the locating agent name as ninhydrin. Ninhydrin over there. So ninhydrin is a substance which is used as locating agent, and purpose of chromatography is to separate and identify, measure RF value, compare the sample of spot with the known substances. Like if it is having someone new, then like mostly the prohibited or abandoned drugs, if some athlete is using, or food which is provided to some celebrities should be checked properly over there. This technique is also used like blood test, sugar test, mostly being done with the help of pregnancy test. Everything is done using this technique of chromatography over there. These were little bit experimental techniques related to this topic over there. After that, I am talking about a little bit periodic table, atom, electron, proton, like that. Atom is the smallest particle of matter, and it is having net charge as zero because on a neutral atom, proton and electron total numbers are staying equal over there. Proton is present in the nucleus over there, neutrons is present in the nucleus of an atom, electron is present in the shells of an atom over there. Proton is having plus one charge, electron is having minus one charge, neutron is having no charge. But if I say what is this 1 and 1, it is having the value 1.6 multiplied 10 raised to the minus 19 coulomb over there, because charge is having the unit coulomb over there. Mass is 1 unit, 1 unit, and 1 over 1840 times. So 1840 times electron is having the smaller mass, but its exact value is 9.1 multiplied 10 raised to the minus 31 kg. In case of proton and neutron, 1.667 multiplied 10 raised to the minus 27 kg, and proton is having also the same mass over there. Location inside nucleus, proton and neutron both are available in the nucleus. Electron is outside the nucleus in the shell, start to rotate over there. And if I talk about isotopes basically we can say atoms of an element would have the same atomic number but different atomic mass, or having the same number of proton but different number of neutrons over there, are called isotopes over there. Electronic configuration, if I want to isotopes example, if I want to give them, then I will say, for example, hydrogen 1 1, hydrogen 1 2, hydrogen 1 3 over there. In that case it is protium, deuterium, tritium, like that. If I take carbon 12 with 6 atomic number, carbon 13, carbon 14, so everyone is having the increasing number of neutron over there. Number of proton like 6 6 6 as atomic number staying the same. If he is talking about electrons shells over there, how many electrons will be there in first shell, second shell, third shell, according to the period number over there, then I will say they should use the general formula of 2n square. For example, 2 into 1 square. 1 square is 1, 2 into 1 will be 2 maximum electron. 2 into 2 square for second shell, that will be 8. 2 into 3 square, that should be for third shell, the 18 electrons. Remember that every element in the periodic table want to complete its octet, or in case of hydrogen or helium, they want to complete their duplet over there, and they are having maximum 8 electrons into the outermost shell. That is called octet rule also. 8 electrons in outermost shell is stable, just like for noble gases, just for to show the noble gases structure over there, except the shell of 1, because 2 electrons and they are stable, like in case of helium over there. And in case of this, like stable is neon, argon, krypton, xenon will always be used over there. So these are noble gases. They don't show any type of reactions over there because they are completely stable over there. And if I talk about elements in a periodic table, then I will say element is a purest form containing only one type of atoms and cannot be split into anything simpler. So elements are arranged in proton order. So atomic number is related to proton number over there. So element is a pure substance. Like if I say the gold is available over there, and gold will stay gold as it is until even though you are reached to the single atom of gold will not have any other characteristics, it will stay as gold over there. That is called element. And in case of periodic table, if we observe here, we will simply say that the verticals are groups. So total they are 18 groups over there. 1 2 3, 4, 5, 6, 7, and 8, and 10 is the between lines. And the total 18 groups are available, and total 7 periods are available. So horizontal rows are named as periods, and vertical columns are named as groups over there. And if we talk about rows or periods determines the number of shells, like total maximum 7 number of shells can be available into the structure of an atom to show the presence of electrons over there. And columns are going to determine the outer electron, valency electron, like in case of except hydrogen, not group 1, and helium not in group 2 should be there. So that is related to periodic table little bit. If we look towards the periodic table, such style is written for us. The number 19 is shown by proton plus neutron. No, it is atomic number. It is showing only the number of protons present in the nucleus of an neutral atom. Then equal number of neutrons, then proton and electron will be there. But for getting number of neutrons, what I will do, this is atomic mass, 39 minus 19 will give me the number of neutrons over there. So symbol, this is a symbol which can be in the form of one letter, two letter, or maybe in three letters sometimes also, but first letter will always be capital letter over there. So mass is related to nucleon number, in which we talk about proton plus neutron, that is relative atomic mass. So average AR of isotope can be calculated. For example, I am giving you here that chlorine is having two isotopes, like chlorine 35 and chlorine 37 over there, with its atomic number 17 and 17 over there. This is present with natural abundance of 75%, and this is present in nature as 25%. And if you take your mass multiply by percentage abundance, like 35 multiply 75 over 100 plus 37 multiply 25, 37 multiply 25 over 100, then average relative atomic mass for chlorine I will get 35.5 gram per mole as molar mass, can be calculated as AR of the isotopes. If we talk according to the group, what will be the valency over there? So valency, if it is belonging from first group like alkali metals, it will be +1. If it is showing +2 from the group 2, +3 as from group 3, +4 and -4 can be taken as group 4 elements. And in case of group 5, it is not easy to lose the 5 electrons as compared to gain 3 electrons. So it is having number -3. And for 6 group, it is showing -2. Group 7 for -1, like halogen family. And noble gases is showing the 0 charge over there. So in the last here in this section, metals versus non-metals over there. Physical properties, if I talk about physical properties, they are good conductors. Metals are good conductors, but they are bad conductors. They are insulators. They are non-conductors. They have high melting point and boiling point in case of metals. They have low melting point and boiling point in case of non-metals. They are hard, strong, high density, malleable, and ductile over there. But non-metals are soft, low density, and brittle. They can easily be broken down to show the maximum elasticity over there. They are shiny and sonorous. They are dull and non-sonorous over there. In case of chemical properties, we will say they lose electrons to form positive ions called cations. They gain electrons to form negative ions named as anions over there. After that, I will say that there is related to molecules. Molecules is basically when two or more atoms bond together chemically over there, they make molecule. And the molecule is the basic unit of any compound over there. So compound containing two or more different atoms chemically bonded together with a fixed ratio by mass over there can be taken into account. After that, we will have to move towards the bonds over there. Bond is basically force of attraction which keeps the atoms together by completing their octets or duplets over there. In case of hydrogen, we say this is talking about duplet, and in case of other elements, we say they will talk about their octet over there. So for this one, I will say, first of all, we will have to talk about ionic bond, which is formed between a metal and non-metal atom due to strong electrostatic force of attraction of positive and negative ion over there. If you look at this structure, remember that the plus sign, plus ion, cation, is making the decrease in size of its original atom. Reason behind that, when atom loses electron, then one shell is decreased, and also when shell is decreased, then I will say there will be more nuclear charge to attract the remaining number of electrons, so the original size will decrease over there. And when original size is decreased in case of cation, on the other end there will be one extra electron or more extra electrons are available to be attracted with same number of protons, and that will be larger in size in case of negative anion over there. If we talk about and it is done because of the complete transfer of electron, like one atom, like metal atom, is losing electron, giving it to negative, make another ion over there, that will be related to ionic bond over there. If we talk about their properties, like melting point, boiling point will be high because they are having very strong ionic bond due to strong electrostatic forces of attraction between oppositely charged ions, and it requires a lot of energy to overcome this force of attraction over there. After that, they are soluble in water, they can easily dissolve in water, and they conduct electricity when molten or dissolved due to free ions over there. If we talk like how, like this is the metal atom potassium, which is losing one electron, coming as a cross in the outermost shell of iodine to make potassium iodide. Magnesium oxide, magnesium is losing two electrons because it is related to second group alkaline earth metals over there, so it can lose two electrons coming towards oxygen to make MgO over there. BaF2, because Ba also is an alkaline earth metal releasing two electrons, and fluorine, two atoms are going to be attracting by adjusting their noble gases electronic configuration over there. In case of cesium sulfide, so sulfide, sulfur having 6 electron, and cesium is from alkali metals losing one electron and making this structure over there. Aluminium trichloride, aluminium is belonging from third group, it can release 3 electrons coming in 3 fluorine atoms outermost shells to produce aluminium fluoride over there. Aluminium phosphide, ALP over there. So in this case, 3 electrons are donated to the outermost shell of phosphorus and completely transferred. So positive and negative and strong electrostatic force of attraction is available over there. In case of covalent bonds, are simple covalent, I will say here is completely sharing of electrons between two non-metal atoms over there, and in which both atoms which are covalently bonded over there are going to share their 1, 2, or 3 electrons with another atoms 1, 2, 3 electrons over there to make single covalent bond, double covalent bond, and triple covalent bond. In case of single covalent bond, I will say that it is like the example is HCl, that can be H like that, or the long chains like alkane over there, and that is single covalent. In case of double covalent, both atoms are showing 1 electron over there, and this is shared by this is shared by this and this, like that, single covalent bond. And element to element, if you want to show the single covalent, you will draw only the one line over there. In case of double covalent, like oxygen with other oxygen is double covalent, carbon dioxide is showing the two double covalent bonds over there, like that, or we can say this is the double covalent bond formation over there. And for triple covalent bond, I take mostly the example of N nitrogen, N triple bond N over there will be used as N2 gas. So these are formed when a pair of electron is shared between two non-metal leading to noble gases. Electronic configuration ions are arranged regularly in giant lattice structure, and they have low melting point, boiling point due to the weak intermolecular forces of attraction. They are insoluble in water except ammonia is a covalent compound, but it dissolves in water. Acids dissolve in water, and alcohols dissolve in water. Remaining all the covalent compounds are going to dissolve in carbon disulfide, carbon tetrachloride, or petrol over there. They don't conduct electricity because they don't have free electrons over there. But in their giant molecular structure, they can do like that. Okay, here he is saying group 4, 4 outer electrons, 4 shared, 0 unshared. Like carbon, like 4 electrons, make 4 bonds at least, 4 bonds at least, 4 bonds at least, 4 bonds at least. So I will say carbon can make all the single covalent, one double and two single, two double bonds, one double triple bond, and one single bond over there. Six outer electrons like group 6 elements over there. Then we can say they have 6 outer electrons, 2 shared. They can make oxygen double bond. I have given the example in O2 and ether case. O can make like this. 5 outer electrons are present, 3 shared, 2 unshared, like N3, like nitrogen. To show the double bond with carbon it can make over there, to show the amine relation over there, or it can make all 3 single covalent to make ammonia like that. And if it is belonging from 7 electrons, 7 outer shell, 7th group over there, it is chlorine, showing the single covalent bond. Hydrogen is having 1 outer electron, 1 shared, 0 unshared, and bonding options are available over there. In the last, I will say macromolecules. Now he is talking about the macromolecules which are related to, we can say, graphite or diamond over there. So macromolecules, melting point, boiling point, high. We can say here the examples as silica, SiO2, that can be graphite, there can be diamond. So for this one, I will say due to the large uh, molecular mass over there to covalent bonds, large atoms of molecules of covalent bonds requires a lot of energy to break. They are insoluble in water due to their large structure, not conduct electricity, no free ions, no free electrons. Only graphite is only the macromolecule which is able to transfer electricity, because each carbon forms 3 covalent bonds and fourth electron is free. Like in metals, it is free for available for flow of current over there. And hard due to the giant tetrahedral structure over there, except graphite that is soft because it is lying in the form of layers which can slide over each other over there. And they describe each carbon atom is covalently bonded with 4 other carbon atoms, tetrahedral structure, diamond structure over there. It is called diamond, and it is used for cutting, drilling, and because it is hard over there. After that, he is showing the graphite structure. Each carbon atom is covalently bonded with 3 other atoms, forming layers. So such type of layers are made. So it is used for lubricant and pencil cause it is soft, and electrodes cause conducts electricity over there. So it is used as lubricant. Graphite, we know that it is used as lubricant, pencil cause it is very soft over there. And electrodes cause it conducts electricity due to parallel layers and having the free electrons over there. If I talk about quartz, if I talk about silica, like each silicon atom is covalently bonded with 4 oxygen atoms tetrahedrally, and each oxygen atom is bonded to 2 silicon atoms over there, and structure is similar to that of diamond. So it is also a giant molecule over there, and it is used to make glass because it is hard over there. And in the last, I will say there is a metallic bond over there, because metals are having free electrons making a sea of free electrons over there. On the other hand, every atom has lost its 1 electron, 2 electron, or 3 electrons depending upon the metal structure. Then collectively there is an electrostatic force between the sea of electrons and positively charged ion cations. Overall holding there is a bond between both of them, that is called metallic bond. And metals have the properties they can conduct electricity, Due to delocalized electrons over there, they are malleable because layers of regularly arranged cation can slide over each other when forces applied. And there is high melting point, high boiling point due to strong attractive forces between the cations and free electrons see over there. After that, what is alloy? The mixture of metal and another element. Another element can be metal, can be non-metal. So physically they are mixed up. They are not chemically combined. That is a mixture, that is an alloy over there. Remember that mostly in the cases of MCQs or short question, he can ask you brass is made up of copper and zinc, bronze is made up of copper and tin over there, and steel is iron and carbon also over there. Properties of alloys from the general pure metal, they are, as compared to that, they are harder due to different size of atoms, which makes them sliding layers harder over there. They are resistance corrosion, they resist the corrosion, and they show the better appearance over there. And this was your lecture 1 over there. For lecture 2, go to the other video and go. I tried to make maximum 3 videos or maybe on 2 videos like that more. So just check your the playlist over there. You will find it. It is a quick revision. Thank you so much for today. See you in the next video over there.